I'm Steve Trowell. I work for the Division of Coastal Management in their permitting and enforcement program out of the Washington Regional Office. Work in this Washington district in Washington and Terrell counties and immediate areas here, and then in Hyde, Beaufort, Bertie, and Hertford counties. But today I'm going to talk to you about living shoreline types, local site conditions, things to look for when designing, and design things to design into your living shoreline. And then at the end, I'm going to talk about construction BMPs, things I like to see as a regulatory staff when I come on site to see a living shoreline under construction. First things in looking at a site and assessing it, is it a suitable site? Because not all sites are suitable for a living shoreline, but one of the first things that I want to look for when I walk onto a site and a property owner is interested in doing a living shoreline is what habitats are there and what aquatic resources are present. You heard Carolyn talk about each one of these things. And in designing a living shoreline, we don't want to impact these habitats too much in a negative way. And things I look for, one of the main things in being in this Albemarle, Pamlico area is that submerged aquatic vegetation. It's a very valuable habitat. It's one of the reasons why the Albemarle Pamlico is so productive in estuarine dependent species. Two is your shellfish resources, like your oyster beds. We want to enhance that habitat. We don't want to bury it. And you heard Carolyn talk about this, and this is sort of rehashing what she said, but when I'm walking onto a site, what am I looking at? I'm looking at how much fetch and how that shoreline is oriented. Predominant wind directions in eastern North Carolina are northeast, southwest, but we do have strong winds in the wintertime from the northeast, southwest. We get strong wind energies as well from the northwest, and we get frontal boundary passages. Today we're going to be visiting Lassiter Landing, and it is on the south side of the Albemarle Sound and subject to a big fetch and taking it on the chin whenever it blows out of northeast, northwest. The next thing is water depths. And the shallower the water, the more that wave is going to have drag on it. It's going to cause it to break if it's shallow enough. And so in designing a seal structure, if it is shallow and that wave's breaking before it gets to the shoreline, and Carolyn touched on this several times, that's the tricky part, is if we're on a high energy situation, the designing and we're going to have to use a wave attenuation structure, is how small of a structure can we get away with. And factors to consider is your water depths, and then of course your tidal range. If your shoreline is oriented, and we are in a wind tide situation up here, so if our shoreline is oriented, say for instance to the northeast, and the northeast winds cause our tide ranges, our wind tides, to come up a couple of feet, we're going to have to build a somewhat of a bigger structure to account for that wind tide and when we're going to see the biggest seas. If it's oriented to the southwest and the southwest blows the tide away, blows it out and attenuates that wave, it breaks it more offshore, we can get away with a smaller footprint. This picture here is of a site we'll visit today. This is Lassiter Landing, and the water is shallow out here. This is a northeast wind blowing about 20 knots that day, blowing straight on shore, and you can see the waves are breaking once or even twice before it reaches the shoreline. So they were able to get away with a smaller footprint there, despite the fact of having over 5 miles of fetch. There's different types of wave attenuation structures, and there's different types of living shorelines. There are opportunities out there where you can just plan a living shoreline and you don't have to use a wave attenuation structure. And as Carolyn touched on, we're up in these big sound systems, and we have some big tributaries to them, big river systems. And so we are, in a lot of cases on the shoreline, where we're dealing with a big fetch, and we have to use a wave attenuation structure. These are some of the design criteria, things that you might want to think about in designing, for instance, a sheet pile seal. Sheet pile seal does have some advantages in that it does require less of a footprint, so we're not covering as much of that shallow bottom habitat that Carolyn spoke to. Probably not as good in high wave energy situations, but things to consider when designing a sheet pile seal is, one, to have 1 inch gaps a minimum of 1 inch gaps that meet or equal 1 inch per linear foot. And I know if you're using different materials, say for instance, if you're designing a sheet pile seal and you're using vinyl, a lot of times those sheets are 18 inches wide. There's more than one way to accomplish that gap. And the purpose of that gap is to allow water circulation and aquatic life movement. You can either every other foot and a half provide a bigger opening, more so than an inch, or I've seen them cut holes in the sheets themselves to allow that water to circulate. You want your seal sections to overlap. This is a general, and this is following what's in our general permit, which underwent a lot of review from the different regulatory and resource agencies to come up with that permit condition. But this is just a general design concept to think, especially in your smaller projects. You want to leave an opening every 100 feet. If we're on a high energy situation or on a longer stretch of shoreline, we might could get away with doing longer sections, but maybe having bigger openings. But a minimum of a 5-foot opening, and the overlap, generally we don't want to see any more than about 10 feet. And again, the purpose of that is to allow water circulation, aquatic life movement in and around the seal itself. And then the height. Again, you're going to want to think about your tides, your water depths, and what kind of wave you're going to see. But again, we want it to be as low as we can possibly get away with. A general thing to think about is 6 inches or less above the normal water level, maybe as high as a foot if we're in a high energy situation. But remember, a vertical structure like that, you're going to want that thing to go underwater in a big storm. It's not going to fare as well as other seal structure like rock. Here's an example of what one looks like when they're constructed. You see the gaps in the boards. They're built similar to a bulkhead where they have a soldier piling, and then they build a frame with a top and a bottom whaler, and then the sheets are attached or screwed to the whaler system. Another example in the Currituck Sound where it was used. This is another example. Purpose of this was to show how they overlap the design. This was 500 linear feet here. This is the same site. Again, this is in Middleton, if you know where Middleton is in Hyde County, on the Pamlico Sound. It's subject to a large fetch, and that vertical structure failed. So the property owner came back and went through the permit process to put in a granite riprap, and it's fared very well. And you can see how that marsh has grown right to the back of the seal. Riprap or oyster bag seals, it's similar to the sheet pile seal. We like to see a 5-foot opening as a general concept every 100 feet. Again, if we're in a higher energy situation, or if there's something driving, site conditions are driving a longer section, you can compensate by putting in a bigger openings, again, to compensate for the longer sections. There's several ways to achieve that opening. And again, the purpose of these openings to allow aquatic life movement in and around the seal. And they may be achieved by either dropping the height of the seal down. You can overlap the seal similar to a sheet pile seal, or you can have gaps that are baffled either offshore or inshore by a smaller seal. Again, seal height is going to be driven by wave energy, your shoreline orientation and your water depths. A seal height of 6 inches to a foot above the normal water mean high water is desirable. Higher energy sites may require the seal height to exceed a foot. And again, we're trying to build the smallest footprint, put the smallest structures we can to avoid those unnecessary impacts. And so your side slopes, you don't want to put anything out there more than any steeper than 1.5 to 1 vertical, with a 2 to 1 more desirable. And in designing those things too, if we are in fact putting in a stone seal, your landward slope can be steeper than your seaward side, again, to help reduce that footprint. This is an example of a seal that was done out of marl, and it's done with an overlap design. This was a vertical escarpment here that they armored at the toe, and then across the opening here, they did an overlap design. It's about 5 foot in between toe to toe on that seal there. This is an example of oyster bag seal that was done, and the baffle, it was done with a baffle. The baffle to open here is the open. The baffle was put in on the back side of the seal alignment. And again, this was done out of oyster bags. This is one where the baffle was put offshore. Rather large structure here that fetches the entire Pamlico Sound. And this opening here is about 30 feet. Here's a seal structure with a drop down, no baffle. They just drop the seal down to allow that water flow. And then last thing I want to talk to you about is construction BMPs. And when I put this presentation, or was asked to do this presentation, I just completed, these projects were done. I'm going to show you two different ones. They were done in March of this year. And this was a major permit riprap seal that was done on Ocracoke, just inshore Teach's Hole. And so it was done out of granite. And the stockpile site for this area, or this project, was here. The high ground, this is a high marsh here. It's vegetated with black needle rush, 3 square, salt meadow hay. On the shore there was fringing alterniflora, and then just stitches spicata. And it was along the shoreline there, as you see, along a lot of natural marshes that are subject to a big fetch and that have a lot of sediment. In the nearshore area, you end up with a sand berm, sand overwash berm. And these sand deposits that you see here, this wasn't a result of the construction that occurred, was due to winter overwash and sand deposition due to that wave action. But again, just to summarize, this is where the stockpile was. I'm going to show you some more pictures of the site. The stockpile of the site, the staging area for the granite material was right here. The site was accessed at 2 points, one being here and one being here. And this picture was taken just after the seal was constructed. The rock was moved from the stockpile by rubber tire backhoe. Logging mats were laid to what we call a rock box. And so this rubber tire backhoe at the stockpile was loaded by a smaller excavator. So he handled each rock individually. In doing that, he didn't grab sediment in loading the bucket, the front end loader on the rubber tire backhoe. And he never took the bottom layer out of the stockpile. And so that he was continually dumping on top of that rock layer, and we didn't get any subsidence or sediment that were taken as, you know, by not removing the rock stockpile completely every time. And then the rock was moved to this rock box and dumped, and then a long reach excavator was used to place the rock. And using this long reach excavator, a lot of times it's more expensive. Not everybody has a long reach excavator. You may have to rent it, but he only had to move twice, and he was able to sit right here. It was about 150 feet of seal that was put in, and he only moved twice. So that reduced his time that it took to put the structure in, and it also reduced the impacts on this marsh. And using the mats, of course, that's more expensive as well to have to use them, but again, it keeps it from disturbing this wetland substrate and damaging what we're trying to enhance. And again, he used a fabric to provide a footing for the rock to sit on to reduce the subsidence, and there's going to be some, but again, using this fabric helps prevent that and provide a foundation for the rock seal. The next site that was done this past March actually was a toe revetment. This is over in a creek off of the Pungo River. This again is a high marsh here. It was an excellent site because of the effort the contractor said used to reduce the impacts, but this is a high marsh, mainly black needle rush here, and then a sediment bank. The sediment bank, the vertical escarpment was maybe 2.5 feet above the normal water level. The rock was stockpiled here and then moved. They picked out one access point, and they matted the entire site in there. These are plank mats. They're about 10 foot wide, 8 foot wide, 12 foot long. And there was a gravel subdivision road that brought him into the site, and then he matted the entire distance across the lot to the initial rock box. This rock box, I think, is 12 by 16, I think is its dimension. And he's dumping out of that 10 cubic yard dump truck into that initial rock box, which is supported by mats. And then the mats were continued down to the shoreline where the machine was working. Used a rubber tracked skid steer to move the rock from the stockpile site to the shoreline, and where it was placed in another rock box, a little bit smaller rock box. This was made out of 1-inch plate steel, and I think that one there was out of 3/4-inch plate steel. A little bit smaller, and then he'll slide that across the mats as he moves down the shoreline. This is the sediment bank shoreline that he was stabilizing, and then the shore, you can see the seal height, or not the seal, but the toe revetment, the elevation of it drop as he gets to that marsh. And as he gets down, there is going to be some, it comes into from the quarry with some fines in it. And this particular contractor, when he gets to the bottom part of the last few bucketfuls, he'll have those. The guy will get off of the rubber tire skid steer and actually load the bucket by hand to prevent from getting those fines in the bucket as they place the material. And this is what the site looked like about 2 weeks later. You got to remember, this is in March, so this is all that was disturbed, and quickly, a couple of weeks into the growing season, you couldn't even tell that they were there. This is the access point that the dump trucks were dumping down. And as you can see, very little area disturbed. And this particular contract in his business design, he figured out that, it cost him more up front to make that initial investment in the mats, but what he found is that he spent less time on the site fixing it and actually saved money in the long run. And this is what we don't want to see when we come onto a site. In this particular case, the contractor didn't have a long reach excavator and had trouble loading his barge from the stockpile, so they moved the stockpile out into the water and were loading onto the barge. This wasn't a part of the permit review, and it was simply done because he didn't have or didn't want to spend the money on the right equipment to move the material to the seal location. Any questions? Yes, ma'am. Oh, I'm sorry.
Thank you for the good detailing information. The one thing I think I missed hearing, I don't know if you covered, how far off the shore do you typically recommend putting the sills?
That's going to be site specific. Most of the time, in my experience, that in the few that I've been involved in, about, I would say 25 feet to 30 feet average. In some cases, it's not quite as far. You heard Carolyn talk about 15 to 20 feet minimum, I think, of marsh is what you're going to want to help attenuate that wave action. If you can get a little bit more, good. But you want to have at least, I would say, 15 to 20 feet of marsh there to help attenuate that wave action, further attenuate it, other than the seal itself. But I've seen it as far as 100 feet offshore. In an extreme case, they put it out there. The average alignment was somewhere around maybe 80 feet or so.
That'll change that goes from a lot. Then you don't get the sill permit. Then you're talking a major permit, right?
Yeah. And right now in North Carolina, most seal projects are authorized by a major CAMA permit, and Kevin's going to talk to that. But similar. You got to think about it. Again, that's all going to be site driven. I think really what you're going to in designing these things, what you're going to want to think about, you want 15 to 20 feet of marsh minimum. And then then you got to think about what resources are there. Am I going to get into some SAV if I move further offshore? Because a lot of times that SAV won't do quite as well in that nearshore area because of the breaking waves, sediment deposition, erosion, that kind of thing. You won't find the SAV in that first 20 to 25 feet below the normal water level. But as in a lot of areas, as you move further offshore, you're going to start to get into that valuable aquatic habitat. We don't want to be burying that if we're having to use a wave attenuation structure like rock. Any more questions?
I'm wondering in a situation where you have a high sediment bank, and we were talking about marsh minimums. In some places, it's going to be necessary to bring in fill, for example. And I'm just wondering if you could talk a little bit about the permitting for the fill, where you should get the fill, should you be matching sediments, and the permit that would require.
Yeah, that excellent question. Yes, in some cases, fill is required. You want to try to match that sediment the best you can. You know, and looking at, in a lot of the conditions and areas that I've been involved in seal projects, it's sand. You know, you're on a sand substrate that's there naturally, and these things are being backfilled with a clean sand. You know, if you can get sand out of a bar pit, it's at the bottom. You know, it's like a washed sand that get rid of some of those clay fines. Again, to reduce turbidity. That, as Carolyn mentioned, marsh will grow on about any substrate that's there. But when we're doing backfilling of these seal structures, sand is used a lot of times, and it's just a part of that review process. And you heard her talk about habitat trade-offs, and so we're going to be looking at those areas that you're going to be filling both with a wave attenuation structure and with fill that's behind it. Elevation is critical. You heard her talk about that, and I'm glad. I meant to mention that in the presentation. Elevation is critical, and Carolyn made a great point. You need to look at what's right and left, and if you want to be real exact with it, you employ a surveyor and get that relative to sea level. What's next door? What's growing where at what elevation? Because it's critical, and you get down to inches. You know, if you're an inch too high, you're going to get less desirable species. So elevation is critical, especially when we're filling behind the seal to give us that width of marsh that we desire.
Would that be if you weren't doing a sill and you wanted to do filling and planting, and what type of permit would you have?
Can you repeat the question so that they got it recorded?
I'm just wondering if conditions are right, so you do not have, or you choose not to do a sill, and you plant and add sediment. What type of permit would that change your permitting?
The permit process would be the same.
Okay.
If filling is involved. And now if you're in a low energy site and all you need to do is plant it, then permits aren't required unless you need to prep the site. You know, if you're in there grading out the site, even though you're above the normal water level or mean high water with your grading activity, that's still going to trip the permit. But if all we need to do is go out there with our dibble stick and make a little hole and plant the marsh, right, then no permit required for that.
Okay, thanks.
There's a question, well, there's a couple back there I see now.
I have a question. Have you gone through any projects which required strictly waterside access to do the sills? I can think of one that might need that.
Well, yeah, and Aaron might talk about that a little bit. I don't know if you were going to talk about Springer's Point, but one, yes, that required, you know, and I think they had to bring the material in by barge and well, actually, yeah, and yeah, there are projects. Well, actually, too, that last slide I showed you, that material, that seal was the one I spoke to that had about 80 feet offshore, and they had to bring that in by. That was put in off a barge. Yes.
Okay.
Yes, that's done.
And do you have any idea of the limitations of wave energy for, say, the rock sill versus an oyster shell sill?
I personally don't have those expertise. I just have to rely on what I observe personally in my corporate knowledge of the work area. Now, there are other people, there's hydraulic engineers that might could help you with that. But I certainly don't have that capability. But there are people with that type of expertise that, some of them may be in this room. Some of these engineers. I just have to go off my personal experience.
Okay. All right. So do you have an idea that you need to use rock if you don't think that oyster will work, or vice versa?
Again, you have to look at that wave, the depth, water depth in the nearshore area. If you got a big mud or sand flat out in front of it and it's a foot deep, and you only have typically on a foot of tide when that wind's going to be onshore at that site, you might. And the two, I think it depends a lot on oyster recruitment and survival. When we start using the oyster bags or loose oyster shell, you need to have some recruitment to that seal to help to seal it, sand it, band it together. And so over time, that thing's going to grow and grow together and become a tighter structure. If you don't have as good a oyster survival or recruitment, it may scatter that shell over a period of time. Look at your recruitment there. You can look at pilings. You can look at hard structures in the water in the nearshore area. And if you're seeing a lot of oyster spat and survival, then that it'd be a good indication that an oyster seal would work well.
Thank you.
Thank you. I understand review on larger projects, but when it comes to smaller projects, we try to, as a designer engineer, try to promote living shores, but when we tell clients that they need a major CAMA permit, and it's so much easier to get a bulkhead or riprap, that's the end of it.
Yeah,
Do you have anything to say?
I'm gonna get into. I'm gonna give a real quick answer to that. Kevin's gonna talk to you about permitting, but there's some things going on within the department to this being one of them. This workshop today to promote living shorelines, and we've been meeting with the other agencies that have purview and regulatory authority over the permitting of these living shorelines to see what avenues and permit processes. If there's any tweaking that we can do to speed things up and promote and sort of equalize the playing field between a bulkhead and a living shoreline. We've had some success with that. And we've just recently presented our general permit. We reduced the permit conditions by at least a third. The permit conditions on the general permit for living shorelines was tremendous. It was about 6 pages of permit conditions. They went through the alphabet twice and put specific conditions on that general permit. So the division, coastal management, has been working to try to reduce the burden on that general permit. But really right now the best avenue is to use that major CAMA permit process, because as Kevin's going to talk to you, we're sort of coordinating that review, and we can actually process it faster than doing a general permit, but at this time. But again, I won't speak too much to that because Kevin's going to talk to it, but there is an initiative and a lot of focus on permitting and living shorelines and what can be done to make it easier on the applicant and property owner.
Any other questions for Steve?
Yes, sir.
This may be for you or for any other future presentations. Have there been any examples using core logs for sills instead of rock?
and it certainly has been discussed in past workshops, and that is certainly a form of living shoreline and a wave attenuator, and it's really sort of a tow revetment, but I have no experience in using core logs, and and really it's just an unfamiliar thing, I think, to most all our contractors and to me too as well. But it is certainly an option of a form of shoreline stabilization.
Anyone else?
Yeah, I'll be here all day.